So we're going to look at simple translations for graphs of radical functions, but we actually know all these rules already. So I'm going to try and remind you of something, and then after that we'll do examples. Remember that if we want to graph f of x equals x squared, that's a parabola that opens upwards, and it starts at the origin. So I'm going to say it starts here. And the things to remember are to go from this starting point, to go over 1, up 1. And then that's because if we plugged in a 1 here, 1 squared, so we plug in a 1, 1 squared is still 1. So that means if I go over 2, then I would have to go up 2 squared. 2 times itself is 4. So that would be up 4. And then, of course, over 3, you can guess. It's going to be over 3. What's 3 squared? 3 times itself. That's 9. And so on. I would just do that again and again and again. And really, I do that on both sides, and I do it for as many times as I can hold on my graph, and that's all you do. So let's graph this. Over 1, up 1. And I do it in both directions. And then over 2, up 4. 1, 2, 3, 4. Remember, you always have to start at the vertex again. So over 2, 1, 2, up 4, 1, 2, 3, 4. So I got that, and then over 2, up 4. And then over 3, up 9. I can do that because it fits on my graph. Over 3, up 9. And remember, you try and make this a smooth curve. And that's as smooth as it's going to be. So that's how you graph the parabola. You remember this stuff. But even if you don't remember this, you can figure this out because you're plugging stuff in here. All of these you plug in, and these are what comes out. So that's great. But what if I have, let's remember how to graph, instead of just f of x equals x squared, what if we wanted to graph f of x equals x minus 3 quantity squared, and then plus 1. So what about doing that? Well, it's almost the same exact thing, so let's take a look. If you recall, this was backwards. Like you think negative 3 means move left 3, but it actually means move to the right 3. That's just how it turns out to be. So so we're finding a new starting place. This minus 3 means move to the right 3. And on the inside of your function, if it's like x plus 3, that would mean move to the left 3. So it's a left and right movement. And then outside your function is up and down. So this actually means move up 1. And that is your new starting place. So actually, all of this is your new starting place. So let's go ahead and plot that new starting place. Well, right 3, 1, 2, 3, up 1. There it is. That's my new vertex. Now I follow the same pattern, but I just start from here. So over 1, up 1, over 1, up 1, over 2, up 4, and it's the same thing. Over 2, up 4, over 3, up 9, and so forth. So over 3, 1, 2, 3, up 9, 1, 2, 3, 4, 6, 7, 8, 9. Yeah, that'll work. So I just follow that same exact pattern, and I get a different parabola. Because I have my squared function, that's why I still follow this. All these numbers do is move my vertex. So it's like a new starting place. Let's look at one more, just to remember. If we have something like this, the only difference was now we have a negative. And if you remember, the negative means that the parabola opens downwards. So what we're going to have here is, well, I guess the same vertex, right? Because it's still a minus 3 and plus 1. So let's move over 3 to the right, up 1. So that's my new start. Except for this time, instead of following this exactly, the negative just means it's opening downwards. So all these words change to down. That's it. That's the only difference. So I would go over 1, down 1. And remember, I always start from my vertex. Over 1, down 1, over 2, down 4, 2, 3, 4, and the same on the other side, and then over 3, down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and same on that side. So, like, everything turns out to be almost exactly the same, except for now you're going downwards. And that's it for this. Try and make the graphs smooth. We're actually going to use the same rules, but for radical functions. So I'll continue this in the next video.